Alright, so here's the MATLAB environment that you'll be using for differential equations, Math 246. Basically what I'm going to do is give you a basic introduction to MATLAB and some of the commands that you'll be asked to use throughout the course, specifically problem set A. Um, Really, we're going to start out with basically going through some operations, some arithmetic operations, and then moving forward to some things that require, um, I guess I'll say uh, more knowledge. Um, so we'll start talking about different calculus things, about how to enter differentiation commands, and all these type of things. Okay, so let's get started. So let's first open a script. So if we open the script, it's taking a second to load. MATLAB is very slow. Very slow. Okay, so the top portion that you see here where the cursor is the script portion. So that's where you'll enter your code. Once you've entered your code, you should so if you look at the cursor, you'll see these run commands, and we'll be using these commands to run our code and see, are we producing the graphs or different items that we want to produce. Okay, so let's start. So the first thing that you need to be able to do is arithmetic operations. Okay, so MATLAB operates based on the order of operations. That is, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction. Okay, so how you would write it according to the order of operations is how MATLAB will try to solve it. Okay, so for example, if I wanted to figure out, well, what is 412 minus, in parentheses, 9 times 36 plus 24, okay, minus 72. Okay, so in this way, what we're telling MATLAB to really do is saying, first, look at these parentheses here. Okay, within these parentheses, it's saying multiply 9 and 36, and then add 24. That is what you're telling MATLAB to do. Okay, then it's saying take this number, 412 minus this number, minus 72, that's what I want. And when you enter that, MATLAB will read it in the mathematical way. So you have to enter things according to the order of operations, else MATLAB will do something different. Okay, so let's try to run this. So here we get, let me see if I can just run this section. Okay, so I'm going to hit run section. When you try to hit run, it tries to save it as a file. I just want to run this section to see if it actually works. So what's happening here is MATLAB is saying that this answer is 8. This is the answer to your problem, and all of your answers will be depicted in this lower screen. And you can separate this command screen from the script screen, but just for the purpose of this video, I'm going to leave them on the same screen. Okay, so that's pretty simple. Let's try another operation. Let's try let's see. Oh, one other thing I should tell you in the beginning is, if you want to separate problems, use a double percent sign. So for example, if I use a double percent sign here, that I'm saying to MATLAB, I want to separate this from the next problem I'm going to do. Basically, you're creating sections within your document. Okay, so MATLAB is going to do that. So if I go to my next line and I enter another double percent sign, you'll see this gray line that appeared, and that's telling me I'm in a different section. So when I hit run section here, it's going to run the current section that I'm in. So if I hit, for example, 2 to the third power, and I hit run section, it's going to so let me see here. So hit 2 to the third. Let's see. You have to, oh, that's what my mistake was. You can't put it on the same line. Okay, you have to put it on a separate line. So if you put in 2 to the third, it'll read it as 8. Okay, so just remember, you don't want to put the percent sign and the actual expression on the same line. You want to put them on separate lines. But you can see that it's in a different section. The answer that it's giving me is 8. It's giving me 8 because it's saying in the section that you're currently in, this is what your answer is. Now, if I go to the previous section and I hit run section, it's going to give me -8, okay? Because in that section, my answer is 8, okay? In addition to that, if, let's say, for example, you want to make a comment about something, if you want the person reading it to know something about the answer you're submitting, you can make a comment. And how you do that is you do it through just the 1% sign. So if I hit the 1% sign, I can write, this is how you do a comment. And what will happen when you go to print this out or you send it to someone, they will see this comment and they'll be able to read it. So if you have a problem where you need to explain to either your professor or the grader what you're actually doing, then you would be using this this feature. Okay, so that's that. Now let's move on to some other arithmetic things. One of the things that you'll definitely be using is I think this is the right name for, I know the command for it, but it's value precision accuracy, VPA. And what VPA does is it gives an accurate measure of the number to some amount of decimals that you want. Okay, so for example, if I wanted to know, well, what is pi to, let's say, 10 decimal places, it's going to tell me what that is. Okay, so let's see, for example, so let's try an example here. Let's try, let me do a different section. Okay, so let's try, and the command for this is VPA. Okay, so in MATLAB, you have to give it commands, okay, to tell it what to do. Okay, so in this case, what I'm saying is I want to have a certain number to a certain number of decimal places. Okay, so let's take, for example, pi. So what you have to do is enter VPA. You're going to enter what are these called? They're like quotation marks. They're single quotation marks. Okay, to let it know that this is what I want you to actually. This is what I want you to actually find the decimal expansion for. And you're just going to enter pi here. And we spell pi out because there's no easy way to denote it in the computer environment. So this is how the computer will read pi. Okay, so we close that with a single quotation mark. Okay, we're going to put a comma, and then you're going to tell it how many decimal places you want. Okay, so let's put 2. Okay, so in this case, let's just hit run. Okay. Okay, and notice what we're getting here. Okay, how many? So notice that it's saying 3.1. Okay, why is it saying 3.1? Shouldn't it say 3.14? And let me just clarify what VPA is doing. VPA is telling how many, so I should correct myself, it's not telling you really decimal places. It's telling you more so each number separately is an element. Okay, so it's gonna say, well, so what you're really telling the computer to do is to give you two numbers. Okay, and you see here the two numbers that it gave you is a 3 and a 1. Okay, and it's saying, well, give me the first two numbers in this. Ignore the decimal place, but it's saying give me the first two numbers, and that's what it's going to give you out. Now, if you put in here VPA 3, okay, you see it gives you 3.14 because you're asking it for three distinct numbers, okay, in this this expansion of pi, okay, including the number before the decimal place. Okay, so let's try, for example, let's try another example. Let's try VPA, and let's put in here, let's put the square root of 2. So let's put 2 to the 1/2 power. And this is another thing. When you're putting in, let me think, I think I have insert on here. When you're putting in powers like this, you have to use like to the 1/2, meaning the square root, or 3/4 or whatever, because you can't put in a square root around the number such that the computer would be able to read it. So you have to put it in as a fractional exponent, and you have to put it in parentheses. Okay, because again, if you have to put it in. So let me just demonstrate. You have to put it in like this. You have to put 2 to the 1/2. You cannot put this. You cannot put 2 to the 1 divided by 2. Because again, remember your order of operations. The computer is going to read exponent first, then division. So it's going to take 2 to the first, and then it's going to divide it by 2. And if we just run this section, we get two answers. The first answer you get is the correct answer, okay, which is 1.412, and that's what this first part is giving you. The second part is giving you the answer 1, because again, the order of operations is different. Okay, so you have to be very careful when you're putting these things in. Okay, so now let's get a precise accuracy for this this number. So we're going to do VPA, okay, and don't forget your single quotations. Okay, you got your single quotations here, and I'm saying, okay, let's try this to give me 3 numbers. So I want you to give me 3 numbers. Okay, so you're saying that's how many distinct numbers in the expansion you want, not decimal places, but that's how many placeholders you want. Okay, and if you do that, you get 1.41. Okay, and again, it's giving you 3 distinct numbers. Okay, and this is your approximation. Now, if you enter more numbers, let's say you want it to 5 decimal places. Okay, it's going to give you that as well. So here you have, not 5 decimal places, 5 placeholders, which is in this case 4 decimal places. Okay, so you see you have the 5 different numbers. Okay, and this is your approximation. Okay, so that's what value precision accuracy is. Remember, it tells you placeholders, not decimal places. Okay, so that's that. The next thing is there is a command called format long. Format long is similar to value precision accuracy, but it's not the same. Format long is going to give you 15 decimal places. Okay, so let's try. Let's try the same number. So I'm trying to compare this. So let's take value, precision, accuracy, and put 15. Okay, and then let's take format. And I'm going to take the same number, and I'm just going to do format long. So this is my command. I'm saying I want format long for 2 to the 1/2. Let's see. Alright, so if we run this, the format long, you see, is giving me this expression. Okay, so there are two answers it's giving me. So the first one is the value precision accuracy one, and the next answer is the format long one. So look at the value precision accuracy first. Notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, I think I counted this wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Is that? Hold up. 1 second. I think I'm. Let me try to separate this. I think I put something in. Let me put this as a separate section. So let's run this section. Okay. If we run this section, we get this. So let's count. So VPA. So the section that we're currently in is the VPA section. Okay. So what we're telling VPA is give this to me with 15 placeholders. So it should be 15 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so value precision accuracy is giving me 14 different numbers. Okay, so why is that? Why is it giving me that? It should give me 15. Okay, well, what's happening? That means that the next digit, the next number, the next placeholder has the value 0. Okay, and that's what it's doing. Value precision accuracy is saying, well, your next number is going to be a 0, and because zeros and decimal places are insignificant, I'm just going to give you the first 14, and that's what it's doing. Okay, so really, in all actuality, there is a 0 after this 1, but the computer's not showing that. Okay, so this is our value precision accuracy expansion. Now let's go to the next session and look at the format long. Okay, so look, if you look here, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, notice you have 15 decimal places. So what format long does, format long gives you 15 decimal places. We're no longer talking about placeholders. Okay, so keep this straight. Value precision accuracy gives you 15, well, not necessarily 15, but any number of placeholders. Okay, value precision accuracy gives you placeholders. Format long gives you number of decimal places. So if you ask value precision accuracy, if you put in 37, it's going to give you 37 different placeholders. That's including the numbers before the decimal point. If you ask format long for an approximation, it's going to give you 15, exactly 15 different decimal points. Okay, if you have questions about that, just email me or something, but I think that's clear. So let's try another example. Let's put here format long, and I'm going to put a different, come on MATLAB, I'm going to put a different expression here. So let's try sine of 0.01 divided by 0.01. Okay, so if we do this, we get, let's run section, we get this number. Okay, and this should look quite familiar to you if you remember from calculus, that near zero sine of x behaves like x. So what's really happening here is you should have a number close to 1, because this is really approximately 0.01 divided by 0.01. So that's a different concept, but this is what the computer's doing. It's taking the decimal expansion for sine of 0.01, okay, and then it's dividing it by 0.01, and it's giving you this number, but it's giving you 15 decimal places, okay, because we're using format long. And just keep this clear. And again, if you have questions about this, feel free to email me or whatever. So that's really the arithmetic part. It's not really difficult. Just make sure you obey the order of operations. Remember that value, precision, accuracy is going to give you a certain number of placeholders. That format long is going to give you exactly 15 decimal places. That the double percent signs separate different sections. So if you want to look at different problems, you can enter it separately. So problem 1, you put a double percent sign, problem 2, double percent sign, and so forth. For the actual comments, you have a 1% sign, and those allow you to explain different things that you're putting in that section. Okay, so that's really the arithmetic part, not too complicated. You just have to keep those words and those tools straight. Okay, so now let's look at some graphical things. So there are a couple of commands that are typically used in graphing functions, and you'll be using this a lot, because a lot of the things that you do in differential equations are you use a graph for. So you'll be doing direction fields. You'll be looking at graphs of not just functions, but graphs of various derivatives and things of that nature. So you need to be able to effectively tell the computer what goes on that graph. Okay, so this is very important. So let me just clear all of this out, and let's talk about the graphing portion. So I'm going to enter another section. Okay, so here there are, let me put these as comments. So there are different ways of telling the computer to do different things. One of those things is easy plot. Okay, and I spelled that wrong. Easy plot. Okay, and what easy plot does is easy plot graphs functions in the coordinate plane. Okay, it's going to graph functions in the coordinate plane over a certain interval. Okay, and notice what I'm saying. Okay, so let me make this clear. Okay, so easy plot graphs functions in the coordinate plane within an indicated interval. Okay, and this is very important. Okay, so notice that I'm saying I made specific that it's graphing functions in the coordinate plane. So that means the regular x and y coordinate plane. But if you remember back to calculus 3, okay, the coordinate plane, okay, is the level set 0. That is, if we think about a three-dimensional space, we have 8 different octants, okay. But if we think about three-dimensional space, the x and y values are now independent values, okay, and the dependent variable is the z-axis, is the result of putting in x and y values, okay. So what's happening here is EasyPlot is, so if we have if you have a multivariable function, so let's say a function of 2 variables, if you have a function f of x comma y, okay, if you have a function f of x comma y, EasyPlot will graph the level set f equals 0, because again, EasyPlot is putting it in the coordinate plane. The coordinate plane, if you recall, corresponds to the level f equals 0 given a 2 variable function like this. Okay, so that's very important when you're graphing these things. Okay, and also I stated that it tells you an indicated interval. So for example, if I put in, let's say, okay, I want to graph sine x. Okay, sine x is an infinite thing. Okay, it travels in both directions, both ways. So we might want to, just look at one cycle. So we might want to say, okay, let's look at 0 to 2 pi. Okay, so let's look at that example. Okay, so let's take in the first thing you need to do in doing this type of problem. The first thing that you want to do is to put the command, and the command is literally EasyPlot. Okay, so you put EasyPlot. Okay, put your parentheses, and that's telling MATLAB that it's going to execute something. Okay, and then just like we did before, we're going to put our single quotations and put the actual function there. So I'm saying let's put sine of x, okay, and then let's close our quotation, and then we have to indicate an interval because EasyPlot deals with intervals. Okay, so we have, let's say, 0 to 2 times pi. Okay, and that's another thing. So notice how I put this here. I put 2 times pi. The computer reads operations. Okay, so when you say 2 pi, you're really saying I want 2 times pi. I want that value. If you just put 2 pi there, the computer's not going to read multiplication. Okay, the multiplication is symbolic in what you're saying, but the computer cannot read it. So you have to put these multiplication things here, else the computer will not read what you're saying. Okay, and then we're going to close this interval, and then we're going to close the parentheses. This is very important. If you don't close the parentheses, the computer will not know where to stop reading your information. So these brackets and these parentheses are very important. You need both of these brackets for the interval, and you need both of these parentheses here, okay, to close the expression. Okay, so now if we just run this section, okay, let's run this. Notice that we get this graph. This is the sine graph from 0 to 2 pi. Okay, now notice this is a single variable function, but remember, all single variable functions are special cases of the two two variable functions, the multivariable functions. Okay, that is, this is still what it's graphing is it's graphing in the plane. Okay, it's graphing sine x in the plane because sine x only exists in the plane. in the coordinate plane corresponding to f equals 0. Now, if we put another function here that's a multivariable function, a function of two variables, let's say a function of x and y, then you're going to need to, it's going to do is it's going to graph the level set. Okay, so let's look at an example that's not a single variable function. Let's look at an example that's a two variable function. Okay, so let's look at, let's say for example, let me see. Let's see. I probably should have written this example down, but I didn't. So let's see. So I'm gonna put here. So one thing that I did not say is how MATLAB determines. So if you put two variable functions in here, MATLAB can't really determine which variable to really deal with. They look like letters until you actually tell the computer that they're not letters. So what you have to actually do, again, and if you don't do this a lot of times, it won't work. In this case, it worked because we're dealing with one variable, and we just told it based on these quotations that we're dealing with a function. So it kind of implicitly knew that we were dealing with a function of x. Okay, but but that's not all the time. So what you have to do is you have to put this thing called sims xy. Okay, and the x and y correspond to the actual variables that you're using, and what you're telling the computer is that these are actually these are symbolic objects. These are objects that I'm doing some operation on that I want you to read as either a function or whatever. Okay, so you need to put that. Okay, another thing is, so let's actually put in the expression I want. So we're gonna put y squared and then minus x to the third and plus x. Okay, so notice something. I'm inputting y squared x minus x cubed plus x. Notice that I put a dot, a period, before this square. That is because I am dealing with symbolic objects. I'm not dealing with a number, let's say 1 or 2. I'm dealing with an object that's forever changing. Okay, so what you're telling the computer is deal with this symbolically, deal with this as a variable, and that's what these dots do. So when you put variables to some power, you need to put the dot in first before you do this. Okay, so let's graph this on, let's say 0 to 2.5. Okay, and if we graph this, let's see what's going to happen. Okay, we get this graph here. Okay, we get this graph, and notice, let's look at the actual code and the graph on the same sheet. Okay, so look at this. The interval is from 0 to 2.5. Okay, that's clear. Now, look at what it's done. It set this function equal to 0. It found the level set according to f equals 0. It found what's on the coordinate plane. Okay, so this should be clear as to what EasyPlot is doing. Okay, so for example, so let's think about this for a second, because I think some of the problems do ask you some of these things. If you are trying to depict, let's say you want an equation, let's say y squared minus, so let's take this one, y squared minus x cubed plus x equal to 5. So what that will be really doing is say f equal to 5. So that would be the level set equal to 5. But EasyPlot cannot it will not graph the level set f equal to 5. Okay, so what you have to do is make it equal to 0, because you know that it will only solve it equal to 0. So you put a minus 5 here. And what that's really doing, okay, is it's plotting the fifth level set, but you're forcing the computer to plot the fifth level set, okay, by putting this minus 5 here, okay, because this will be the equation. If you were to do it, you would have y squared minus x cubed plus x equals 5, okay? And you're saying this expression is equal to 5. This expression is f. F equal to 5 corresponds to the level set f equals 5, okay? Well, again, EasyPlot will only give you the level set f equals to 0. So what you're doing is making this into y squared minus x cubed plus x minus 5 equals 0, because the computer can own the EasyPlot command will only do this for a level set equal to 0. So you have to write it in this fashion, okay? And that's exactly what we did here, okay? So if we look at this one, it'll look like this. Let me run this section. You have to give it. Sometimes you have to give it a second because MATLAB is crazy. Okay, so if you look, this would be our levels. This would be our level set. Okay, but this is really the level set f equals 5. But we have to put it in this way because EasyPlot will only deal with the level set 0. But putting these different constants here will implicitly change effectively change the level set without having to do any additional steps. Okay, so that is really the graphing portion. Another thing that is used a lot is inline. Okay, and inline really is just a way of identifying a function. Okay, so inline is a new. So let me put a new command here. So a new comment. I mean, so inline. This function it basically identifies the function. It basically identifies it. So basically, inline identifies. I can't spell. Identifies the function. Okay, that is, when you use inline, okay, you're going to put whatever function you have, but you're going to specify what is the independent variable or the independent variables. Okay, you're telling it that this is a function of x or a function of y or whatever. So for example, you could, so let me put this in a different section, because yeah, let me put it in a different section. So what you're telling it to do is look at this specific function. So let's say, for example, we want to. So sometimes in MATLAB, you need to assign functional names for things. You need to assign names for things just to keep your code straight and for you to understand what you're doing. So you might want to call something y. So let's say we want y equals inline, and we're using inline because we want to specify a function. So inline tangent, we're going to use our quotation marks again, tangent of x. Okay, now you're telling the computer this is a function. Okay, but now you need to tell the computer, okay, what type of function is this? This is a function of what? Okay, you're telling it is a function of x. So let's put x here. We need to put our quotation marks again. Okay, this is your argument. Okay, your argument is x, the independent variable. That is what tangent of x depends on. That is what you're telling the computer. You're telling the computer that this is a function, okay, and then that is a function of x. And I'm going to be using this function in some operation that I'm doing. So let's say we wanted to plot this function, okay. All you would have to do, again, we're going to be using easy plot. So easy plot, and then you put y, because that's the function that you're actually using, is y, okay, and then you're going to give it some interval, because you always have to give intervals for easy plot. Let's say negative pi to pi, okay, and keep in mind, again, negative pi, you can't put, you can't put it in like that. You have to put -1 times pi, okay, then put pi, okay, and then put your thing here, then put your thing here, okay, and then it will give you the graph. So pi is approximately 3.14, and you see it's giving you something like -3.14 to 3.14 as the interval, and then what you also have is the actual function. You told it to graph this function, and you told it to graph tangent, and that's what it did. Okay, so you're going to be using these things to graph things. So you need to understand what the computer is actually doing. Let me see. Are there some other graphing things? Now, another concept that you often need to do is you need to graph more than one thing on the same plane. Okay, so how you actually do that, okay, is by actually holding on to another function. So what you'll be doing is you'll be making two functions, okay, two separate functions. And what you'll be telling the computer to do is to plot the first function and then hold on to the second function. Okay, and that's going to tell it, well, I want to put both on here, so I'm going to hold on to this one. I want both to be on here. And that's what you're going to be doing. So I'm going to show you how to do that next. Okay, so if we move to the next section. Okay, move to the next section. Let's say I want to create a function f and g. Okay, so let me start off by putting my sims x, again, because I'm dealing with symbolic things. Okay, let me put sims x. Okay, then I'm going to put f equals x to the 7th. Or no, let me put to the 8th. And then don't forget your dot here. And then I want g equals 4 to the x. Okay, 4 to the x. Okay. And well, these are my two functions. Now I want to actually plot these functions. Okay, and now, so I'm going to show you something else. I'm going to put semicolons behind these. Okay, why am I putting semicolons behind these? I'm putting semicolons behind these because when I print it out, I don't want MATLAB to read them as actually things that it's solving for. I want it to store these functions. Okay, I don't want it to actually execute an operation on these functions. So I'm going to put semicolons behind them. And then I'm going to put, so I want to graph these and put them on the same plane as I said before. So we're going to put easy plot, f, okay, and then let's put an interval, let's say -2, 2. Okay, and now, this is one function. Now you've told the computer to graph f. Now you want to graph another function, but you want them on the same plane. So you're going to put hold on, okay, and then you're going to put the next function. You're going to tell the computer to plot the next function. But when you're telling it to plot the next function, okay, what you're doing is you're saying now plot G, okay, but plot it on the same plane, okay. And if we do that, well, we want it on the same interval as well. Here, okay. Now you can put other functions. You can put as many functions as you want on the same plane, okay. Well, how will the computer know when to stop putting functions on the same plane? You have to end the command. So you put hold on, now you need to put hold off, okay. And that is how you tell MATLAB to do that. So what you're going to see on this next diagram is you're going to see F being graphed, G being graphed, but them being on the same plane, okay. So let's run this. And this is the graph that you get. Okay, this is the graph that you get. Okay, you get this this graph of the polynomial function, and then you get this exponential function, and you're seeing, well, that they intersected these two places. And for some reason, you might find that as being useful information or what have you. Okay, but this is what happens, and this is how you have to tell MATLAB what to actually do. Okay, let me see. There are some other things that you need. Let's see. And with this, there are a lot of different commands for things. So, you know, it's gonna take time. Okay, but if you just kind of stick with it, you'll be okay. MATLAB is really not hard. It's just you gotta get certain things down to be able to process certain things. So let's look at it's about 3 more different commands. So I know this video is getting kind of long. It'll probably be an hour video just because I have like 3 more commands that you definitely need to be able to put into MATLAB, especially for these are just kind of basic things. Okay, so another function that is often used is I'll come back to that one. Is especially in calculus and differential equations, is limit, differentiation, and integration. Okay, and that's literally something that we might want to do. Okay, so this is how you're going to input it. I think this shouldn't take that long for these couple ones, because I mean, you know what limits are, you know what derivatives are, you know what integrals are. Okay, so what if we want to take the limit of tangent of x over x? Okay, what if we want to take that limit? Well, where are we taking the limit from? Well, let's take it as x approaches 0. Okay, so how do we put that into MATLAB? Well, you literally put limit. Okay, you put limit. Okay, you put the function. Okay, let's see, tangent of x divided by x. Okay. Okay, so that's the expression. Okay. Now you need to tell it, well, what is the independent variable? What it's varying in this limit? Well, x is varying. Now, what is x approaching? X is approaching, some number, let's say 0. Okay. So let's see. So let me see. I think it's still trying to it's kind of slow. 0. Now, sometimes you might want to approach 0 from the left, 0 from the right. So you can also specify that. So let's say we want it from the right. So we put, now we're going to need quotations for this. So we put from the right. Okay, and then we close it. Okay, don't forget your sims x, because you're dealing with a function of x, a symbolic object. Okay, so if we run this, it gives us the answer 1. So that's saying the limit is tangent of x, the limit of tangent of x over x as x approaches 0 from the right is going to be 1. Okay, now let's see from the left. Well, what if we change this to the left? Okay, well, from the left, we also get 1. So that means that the global limit is 1. Okay, So you can tell MATLAB to do these different things. Let's look at another command. Let's look at the differentiation. So the differentiation is you're just telling it to differentiate this function. Okay, but remember these functions are symbolic, so you have to use sims x. Okay, so the command for it is just diff. Okay, which is clear. Okay, you enter the function. Let's say you want 4x 4x to the third plus 2x square plus x plus 3. Okay, and it's going to differentiate this thing. So let's see what we get. Wait, we got an invalid statement. We got an invalid statement here. I know I put it in right. Let me see. Let me see. I may have put sims x. I don't think you can. Yeah. Oh, okay. I see. What I did wrong, okay, and remember I told you this earlier, MATLAB cannot read multiplication. We do multiplication implicitly, okay, but MATLAB can't just do it like that. So you have to tell it. So what I should have put here is multiplication. I should have put multiplication signs here. Okay, you have to do that. If you don't, you get an error like I just got. Okay, so now let's try this. Okay, and you see it differentiated for me. It did the 4 times the 3, which is 12x squared, and then plus 4x plus 1. Okay, so it differentiates the function. Okay, and again, this is a symbolic expression. Okay, so you have to put sims x and all of these different things. Integration is it's pretty much the same type of deal. You're gonna put the command for the integral, and then you're going to put the function, and then you're going to put what variable is the dependent variable. So what is your variable of integration, and then you're going to put the actual limits of integration. Okay, so for example, let's say we want, let's say sims x, and the command for integration is just int. Okay. And let's say we want to integrate, what do we want to integrate? Let's say we want to integrate cosine of x, okay? We want to integrate just cosine of x, okay? Now, we want to integrate this, and then we want to put our variable of integration. Our variable of integration is x, okay? Now, if you want what is it called? If you want an indefinite integral, okay, you just put the x. Okay, so if we put just x, it's going to give us sine x. Okay, now MATLAB is not as smart as we are. MATLAB will not put the plus c. Okay, it's going to give you an antiderivative, but it's not going to give you the entire family of antiderivatives. It's not going to put the plus c here. Okay, so you have to know implicitly that, you know, this is really a family of solutions that you're really thinking about. So you have to be a little smarter than the computer. Okay, now if you actually wanted limits of integration for this, then what you would do is you would add them. Okay, here. Okay, so let's say you want to go from 2 pi to pi. So we put 2 times pi. Remember, we got to put that multiplication. I should have put negative 2 pi. Negative 2 pi times pi to pi, and close this, and it's going to compute that integral for me. Okay, and the integral is 0. Okay, and that should make sense. Well, why is it 0? Well, negative 2 pi. If you think about each hump, okay, negative 2 pi to pi, it's gonna cancel out some things. Okay, so it's good. This is the answer to the problem that we're dealing with. Okay, so this is clear. I don't think it's now. Also, Another thing I need to say about this, you can input negative infinity and infinity in here as well. Okay, so if I wanted to, let's say for example, I wanted to find out what is, let's see, 1 over x. So let's take 1 divided by x as our function, and I want, well, what is my variable of integration? My variable of integration is x, and then I'm going to go from let's say I want to go from 0 to, or we can go from let's go from 0 to infinity. Okay, so 0 to inf. Okay, and that's how you denote infinity, by inf. Okay, so you put it in like that. Okay, and it's going to tell you, well, this is an infinite area. Okay, your answer is infinity. Okay, you can also put negative infinity by just putting -1 times inf. So I'll put that as a comment. Negative infinity is just -1 times positive infinity. Okay, and that's how the computer will read that. It's not a lot left to really look at. Says some general things. I'll put these as comments. If you want to be more technical with your graphs, which your professors probably might, or they may or may not, but they might want you to be more technical with your graphs. Okay, so they might want you to have equally spaced axis. So if you want an equally, so let me put equally spaced axis, then you need to use what we call axis type. That's the command. And axis type will give you equally spaced axis. You can make your axes go from different numbers. Okay, so if you want to do that, you would say, okay, so you first look at your x-axis and your y-axis. Okay, so you use this thing called axis. Okay, and then you put the x's first. So let's say we want our x values to go from -2 to 2, and then we want our y values to go from 0 to 2. Okay, this is how we would input it. Okay, so what would happen here is you would have x's going from -2 to 2, and y's going from 0 to 2, and that's how that's what your axis would read. You can also put axis labels, so you can label your axes, x and y axis. So what you literally put is x label. Okay, if you want to label the x-axis, let's just call it x-axis. And you have to put these single quotes as well. Okay, same thing for, you can label the y-axis as well. So y label, put y-axis. Okay, and that's pretty. I think that's pretty much the gist of the basic stuff in MATLAB. Let me see. Is there anything else before I end this video? I don't think. Let me see. The only other things, and I'm really trying to wrap this up, guys, is factor, solve, and factor, solve, and I think that's it. Factor, solve, and F0 and sim. Okay, so I'm going to end the video here, and then I'll do another video. The next video should be very short. The next video will talk about how to put in series from Calculus 2, how to put in those series expressions, and it will also tell you how to factor different things and to solve different systems of equations and whatever. So I'll put that in the next video because this video is getting kind of long. So for now, that's it.